Alright, in the previous video we were determining if lines were parallel, perpendicular, just intersecting, or coinciding. One of the main things you're going to have to do is to find the equation of a parallel line or find the equation of a perpendicular line because those slopes have very specific relationships. So to find a parallel or perpendicular line, you're going to be given a line and they'll say, okay, find another line that's parallel or perpendicular through a given point. Sometimes they'll have you find a midpoint of a segment, especially if you're doing a perpendicular bisector. So here are the steps. Step 1, find the slope of the original line. That's M. So you can call this M old. Sometimes it helps to label things. So we're looking for the M of the original line, okay? If you're given 2 points on the original line, use the slope of the line formula from your math chart so you can see it right there on the screen. If you were given the equation of the line, make sure it's y equals mx plus b, the slope-intercept form, so that you can look for slope, m, which is the coefficient, the number in front of x. In step 2, you're going to find the slope of your new line. If it's parallel, this is really easy. It's the same. If it's perpendicular, it's a negative reciprocal, and you have to change the sign, because it's negative, and flip it. Finally, you're going to use the point slope form with the new slope. If it's parallel, it's the same. If it's perpendicular, negative reciprocal. And you're going to put it through the given point. A lot of the times in the examples, you'll see me just call this x1 and y1. Sometimes it can be a little confusing. Now, we prefer to see the slope-intercept form as an answer, so you will probably need to solve it, especially since we use the point slope form so much in step 3. So you'll need to use a distributive property and multiply everything through. Now, perpendicular bisectors are a special case. So you're given a segment and say, find the equation of the line that's a perpendicular bisector. You need to find the midpoint first. So you're going to need to find the midpoint where this line is going through and the slope of the original segment. So let's look at example 2. Write the equation of a line perpendicular to y equals negative 1/2 x plus 9, and that goes through the point 4, 2. So the first thing to notice is the slope is negative 1/2. That's the old slope. Because this is perpendicular, we need to do the negative, which means change sign, reciprocal. So if I flip 1/2, that's 2 over 1, or just 2. Since it's negative in the old slope, it's positive in the new one. Now I'm going to label my point that it's going through x1 and y1. And we're using the point slope form of the equation. So you can see, well, there's my 2. That's going to go into the slope. Then I need to figure out what y1 is, because that's going to go through, that's part of my equation. And I also need to know what x1 is. In this case, y1 is 2, x1 is 4. It might feel weird because the y is kind of coming before the x. It is in this equation. Notice that I don't fill in for the regular x and I don't substitute in for the regular y. So substituting in, I have y minus 2. This 2 came from up here. Equals 2. That 2 is actually from the slope. So this is the slope here. And then this one, this 4 is from my original x1. Use a distributive property to multiply the 2 times the x and the 2 times the negative 4. So you get y minus 2 equals 2x minus 8. Add 2 to both sides, and you get the equation in the slope-intercept form. Y equals 2x minus 6. So it has a slope of 2 and a y-intercept of negative 6. All right, in example 3, we're going to write the equation of a line parallel to 3x minus 2y equals 12. This is in standard form right now, so that's not going to be very helpful. We want point slope form. We also know that it goes through the point 4, 2. So first of all, let's get this equation into point slope form. I subtract 3x from both sides, and technically that's negative 2y equals negative 3x plus 12, but I just want y. So I divide everything by negative 2, and I get y equals 3/2 x minus 6. Because it's parallel, we're using the same slope. So m is 3/2. Now I also know this is x1 and that is y1. I'm going to use the point slope form. So y minus y1 equals m times x minus x1. I substitute in here. I don't substitute into just the regular y or the regular x. Substituting in the 2 for the y1, I get y minus 2 equals 3/2 comes from the slope, x minus 4, you see the x1 here. Distribute the 3/2 into the parentheses. So I have 3/2 x minus 12/2. If you're not quite sure how I got that, all I did is I did 3/2 times 4/1, and that will give you the 12/2. Then 12/2 is just 6, so y minus 2 equals 3/2 x minus 6. I can add 2 to both sides to get my final answer, y equals 3/2 x minus 4. In example 4, we want to write the equation of the line that is a perpendicular bisector of the segment. So I have the endpoints 0, 4 and 12, -2. So the first thing I'm going to do is label my points, and I'm going to find the slope. So m equals y2 minus y1 over x2 minus x1. Substituting in the points -2 minus 4 over 12 minus 0, I get -6/12 or -1/2. Now it's the perpendicular bisector, by the way, so I'm not actually going to use that slope. But before I do that, let me go ahead and find the midpoint. So there's that slope. We're going to flip it. But let's find the midpoint right now, and all I do is add the x coordinates and take the average. So 0 plus 12/2 is 6. That makes sense. Halfway between 0 and 12 is 6. 4 plus -2 all over 2 is 1. So 4 plus -2 is 2. Divided by 2 is 1. That might be a little harder to see, but if you graphed it, you would see it. So my midpoint is 6, 1. The next thing I'm going to do is use that midpoint and my slope to substitute into the point slope formula, which I take straight off the math chart. So I know that y minus 1 equals 2 times x minus 6. You can see where the 1 comes from, and you can see where the 6 comes from. And the 2 comes from the slope. Remember, we flipped it and changed signs. That's called the negative reciprocal. Then distribute the 2 in through, and we've got y minus 1 equals 2x minus 12. Add 1 to both sides to isolate the y, and we get y equals 2x minus 11. So the reflection for you today is, can two lines have positive slopes and be perpendicular to each other? If you can't quite remember, it was one of the first videos where I showed you the lines rotating. So that might help give you some ideas for this answer.